Hello, today in the lesson we will study an example problem on the law of conservation of momentum. The problem is as follows. A young hockey player standing on the ice holds a bag with a mass of 1/30th of a kilogram. Then he throws it with an initial velocity of 6.5 meters per second at an angle of 11 degrees horizontally and rolls backwards at 0.25 hundredths of a meter per second. Find the mass of the hockey player. So, the mass of the hockey player we can denote as m large. I take into account that we have here two objects. The small one is a bag with a mass of 1.3 tenths of a kilogram, and the hockey player can be labeled by the letter m big. So we know that he throws the bag with a velocity of 6.5 meters per second, and the angle of throw here is 11 degrees to the horizon. It's also known that he pulled back after the throw at a velocity of 0.25 hundredths meters per second. We have all the data in CIP, so we will not translate anything, and now let's see how such a problem is solved using the law of conservation of momentum. What can be done at the initial stage? Of course, in such situations we must show the state of the system before and after the throw, so that we can see what the momentum of the system was before the throw and what it became after the throw. Let's draw these two situations. First of all, we understand that this system was at rest, which is the hockey player himself. At this bag, we're in a stationary state. That is, the initial velocity of this system is 0. So we'll sign here. This is what we had before the throw. What do we get after the throw? The bag is flying relative to the horizon at velocity v1. This angle was 1 degrees. That's m small. Accordingly, the hockey player himself started moving in the opposite direction, so he can move strictly on a horizontal surface, but with velocity v2. Now our task is to calculate the total momentum before and after this throw. What is obtained at the initial momentum? That is, the total momentum for the given system before the throw, as we see, will be equal to 0. The total momentum after the throw. Well, what we see here is that there's a motion of two objects, and we must consider these momentums on the axis of human motion, because here we see that the motion of this bag occurs in two directions. And our task, if we want to consider the motion of the man himself and consider his mass in this motion, then we must consider the components of these momenta on a chosen axis. Let's assume that we denote its axis x. Then it turns out that a components of the given vector on the x-axis and the sum of these vectors will be decomposed as p1 and p2 in projections on these axes. Further, our task is to describe in scalar form these quantities, and, as we understand, in projection on the x-axis, we will apply this law of conservation of momentum in terms of equating these momenta. Of momentum, we will apply in terms of equating these momenta, and then calculate the values we need. So it turns out that the momentum prior to this throw will be equal to a momentum after this throw. Now, if we're talking about scalar quantities, then of course we need to take into account the direction of each momentum on the corresponding axis and calculate its component. So we get that the component of the first momentum, which is the momentum of this bag, is the product of its mass and its velocity, and, as we understand, it will be the calculation of the adjacent cathetus in this triangle, that is, by the cosine of this angle. The momentum for this person, the hockey player, we see the velocity is directed in the opposite direction against the x-axis, so it acquires a negative sign. And here we've got the velocity all in the plane of the axis, so just multiply by v2. In scalar form, the law of conservation of momentum will look like this. Based on this equation, we see that it is possible to calculate the mass of this hockey player. In order to do this, here we transfer the momentum of the bag to the left side with a minus sign. So we get minus m times v1 and cosine I. And then divide by the negative value of the hockey player's velocity. The minus here goes away, and we are left with the final expression. So, you and I have got the final formula for calculating the mass of the hockey player, and all that is left is to put the numerical values. The mass of the bag is 1.3 kilograms, the velocity is 6.5. Cosine of 11 degrees, and divided by the speed of the hockey player. After the calculations, we get a rough answer of 7.7 kilograms, which is actually quite a realistic answer for this problem. A young hockey player may well have such a mass. So, today we've looked at an example of solving a problem using the law of conservation of momentum. And so, applying this methodology, you can solve problems of the same plan or even more complicated. That's all for now. See you later. Goodbye.